Hey folks, I've had some questions on number 18 from your homework, so I thought I'd make a quick video where we're going to solve this first order ODE using the variation of parameters technique. So remember, the first thing we want to do is we want to find a solution to the homogeneous equation. So the homogeneous equation is y prime minus y equals 0, or y prime is equal to y, and of course this is separable, so we could write that dy over y is equal to dx. Integrating both sides gives us natural log absolute value of y is equal to x plus c, or that y is equal to ce to the x. So this is the homogeneous family of solutions to the differential equation. And in our technique of variation parameters, what do? Well, we first solve that homogeneous differential equation, and then what? Well, we're going to pick one solution from it, so let's go ahead and pick c equal to 1. That's the best choice, but we could pick other values. And so we're going to use the solution yh equals e to the x, and then we're going to posit that the particular solution looks like some unknown function v of t times e to the x. Okay. So let's see what we can do here. We need to figure out what this unknown function v of t is, so we go ahead and differentiate our guess at the particular solution, and here we're going to have to do the product rule. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first. There's my product rule, and those should be x's there, not t's. Okay. So now we go ahead and plug the particular solution's derivative and the particular solution into the original ODE. Careful, not the homogeneous ODE, the original ODE. So this gives us v of x e to the x plus v prime of x e to the x. All of this is my y prime minus y, which is v of x e to the x. That's my y, and we want this to equal 3e to the x. Well, notice, as we saw in class when we derived this, that the two v of x terms cancel out, and so we're just left with v prime of x e to the x equals our non-homogeneous function. In this case, things work out actually fairly nicely, in that when I divide both sides by e to the x, I just get the constant 3. So solving for v of x is just simply integrating the constant 3, and so we end up with x plus c. Remember, we're just looking for one v of x for which this works, so let's go ahead and pick c equals 0 just to take the easiest solution. Oops, and that should be 3x plus c. So we pick c equal to 0, so we're going to use v of x equals 3x. So we're now ready to give the general solution, because the general solution, y of x, is just the one particular solution plus the family of homogeneous solutions. And so y of x is equal to, what is yp? It's not v of x. It's not just 3x. It is 3x times that one particular homogeneous solution. So we get 3x e to the x plus our entire family of homogeneous solutions, which is c e to the x. And here we have the general solution to this ODE. I hope this helps. If not, let me know.